for this NOAA Office of Education Cooperative Science Center is City College of New York. And our partner institutions are Hampton University, San Diego State, University of Maryland, Baltimore County, University of Puerto Rico, Mayagüez, and the University of Texas, El Paso. Our goals in this research center, it's threefold. We try to tackle science by providing all the students with cutting-edge research in remote sensing science technology that is aligned with NOAA's mission goals, and that research supports the NOAA line offices. Our primary goal here is the education component, and it's not just in the academic side, but also to provide you all the skills necessary in STEM-related, STEM and social science-related topics that are aligned with NOAA's future workforce, or at least what you might be engaging down the road. And also, we want to inspire the next generation, as many of you students that are part of the program and the ones that are interested in the program, the key element here is to be able to attract you to our institutions, or if you're within our institutions, to conduct research that is aligned with NOAA sciences, and at the same time to you to be a person that would engage the younger generation in K-12 and at the college level as well, to kind of line up or make people aware of the benefits of conducting research and being part of the NOAA workforce. Our efforts here, as I said, they're very focused in the education and the training, providing you all the skills. And there's different elements that we cover, from the academic and professional core competencies that we provide, in which we provide you a very diverse set of academic and skills assessments on different topical areas, from remote sensing, programming, social sciences, among many others. Also, the being part of this research center does allow for conducting research at NOAA facilities, being involved with the current NOAA workforce, to kind of, at the same time, be your mentors and mentors to the students as well, mainly to kind of guide you into where the NOAA mission goals are kind of headed, what are the skills, and with the idea that at the end of this program, you do have a greater probability of joining that NOAA workforce, either as a civil servant or a contractor for NOAA. We are, to all throughout your participation in this program, we are continuously assessing and evaluating your progress. So it's not that you're going to be just thrown into a research program without proper guidance. So there's proper mentoring that occurs at each campus from the different academic mentors that you may have in your institution, the NOAA collaborators, and as well as the different resources that we can provide you through our education outreach program. We do as well, we do track, what you're doing after graduation or participation within the program, because as everything, it's an evolving program, society evolves. So we want to make sure that all those opportunities that we provide you here, they're taken to full advantage down the road. So it's very important for us to know after you graduate where you're headed and where you're at. As mentioned earlier, kind of, repeating theme that you'll hear over and over, recruitment and retention. That's one of the key aspects here. It's not just joining the program and you falling through the cracks. We make sure that you have all the opportunities available to you to succeed in the program. And last but not least, there's a whole component of professional advancement and career engagement that we also emphasize in all of our students. In terms of the thematic research areas, we have 3 of them, and there's coastal resiliency, atmospheric hazards, and water prediction ecosystem services. Those are the 3 main areas, and the subcategories here are the different areas that we actually address. There's more to that, but these are the more frequent ones that, a lot of our students are interested when they join the program. With that said, we do have integrated to all those scientific research thematic areas a social science component in which we, based on the projects that the students are engaged and involved, we channel those efforts to we identify what are what's within the social science framework, what's the most appropriate topic. Is it public health, planning and policy, population science, or environmental economics and sustainability science? One of the key missions here is to, as any funded research program that is out there, we have to make the taxpayer aware. And there's many stakeholders at the federal and the local level, and we have to be able to let them know what is our goals and missions and why the relevancy of our work in the local community. So that's a key element that we make sure that all along, all our students are aware of as a part of this research center. With that said, we come from different points of view, and I like using the figure to the right, which is just a picture of a fly, and it has to do with the compound view of a fly. So you have all these different satellite observing systems in space. They're all being used for different particular areas of interest, but here in CREST, we can actually, when we do have within our research that polyphysetic type of approach, and we can tackle different areas of interest to society, as disaster management, ecological forecasting, public health, energy management, carbon management, agriculture efficiency, water management, and air quality. So if you have any type of interest in any of these topics, it's very easy to be integrated, for you to be, integrated into our sciences. So there's room and space for very diverse set of interdisciplinary research in that regard. And also today the talk is going to focus more on some of the stuff that we are doing at UMBC, and that kind of mirrors some of the university partners in atmospheric hazards, because that's the area that my campus focuses in. In particular, we're talking about remote sensing and environmental technology and how we put that into use. And listed, you'll hear several topical areas like remote sensing, cloud aerosol properties, optics, spectroscopy, atmospheric dynamics, wind energy, air quality. So depending on the area of interest, and it doesn't, even though we label atmospheric hazard, doesn't mean that you have to be a major in atmospheric science. You can be a computer science major, you can be an electrical engineer, mechanical engineer, social sciences for that matter. Well, you can be an economics major. So the research itself, well, we have these subset of topical areas that if they fall within your interest, you can be part of. But at the same time, the research within the atmospheric hazards is very interdisciplinary in nature. Regarding air quality, one of the key areas in which we have aided state air quality management agencies, like the ones here in New York and the ones in Maryland and Virginia, is, for example, what's the impact of having pollutants from other locations impacting our neck of the woods at the local level? Also, how can we use this remote sensing technology to identify the transport and to try to determine, what's the composition of these particles from space, to kind of then, try to identify what might be the source of origin. In terms of the research that we do at UMBC, there's at least 5-tier areas. One of them involves, development of algorithms to obtain these optical, physical, and chemical properties of aerosols and gases. We go into boundary layer dynamics. A lot of that, you see the applications into air quality and wind energy, and we'll cover some of those. And this has to do more with air quality, but at the same time, goes into just climate and global models, continental and intercontinental plume transport, and mainly to the eastern U.S. And we'll talk about that because the CREST Cooperative Science Center has a unique research infrastructure that we can provide a lot of information and context regarding transport of pollutants to the East Coast. Traditionally, we have correlated satellite measurements, the aerosol optical depth to surface PM2.5 measurements, and try to pretty much generate a 3D picture of particle pollution in that regard by combining the observations from surface air quality monitors with LiDAR or profiling techniques, and then the satellite observations from space. Last but not least, and it's an area of a lot of interest for the engineering student, remote sensing technologies for different atmospheric observations and applications. In terms of air quality, as I mentioned before, the nice thing of using some of these remote sensing technology is that you can have there's each type of particle or gas out there. They have their own distinct kind of fingerprints of that we can identify and know of their presence in a particular region. So that allows us to do a proper assessment of the optical, chemical, and physical properties of those pollutants. Also, and this is kind of going back to what I mentioned in the slide before, because we can combine surface and the profiling that we can do in the atmosphere with the satellite observation, we can generate a 3D picture of what's out there in the atmosphere. And it does allow us to then correlate satellite or ground-based column observations to what we are seeing at these surface air quality monitors. Also, a key element is to look at differences between the diurnal variation, not just at the surface, but also on the vertical, how things are evolving throughout the day. There's several ways of looking at the evolution of the air masses that are impacting all localities. And also to kind of look at, what we're seeing in one particular part of the country, how much translates or how much can we predict that it would evolve at a later time in other locations. So that allows us to look at that horizontal scale variability and compare it, and see how satellites capture that and how the models actually are properly responding to those observations. In terms of Earth system observing platforms, before 2016, we had successfully had operational what's known as the CREST LiDAR network. So LiDAR is the acronym for light detection and ranging. So all these sites that you see here, City College, UMBC, Hampton, and University of Puerto Rico, we have infrastructure in place in which we can know how much particle pollution is present in the atmosphere. In 2013, the White House recognized us as one of 3 air quality observation systems in the United States because of this work that we carry out. So we do have the infrastructure and the expertise, and this is kind of opening up to all the students. Well, you might be a student here at City College, and you're interested in, for example, some of the events that happen either in the Mid-Atlantic or even in the Caribbean. And just to put it into perspective, we have in the Mid-Atlantic and the New York area, we tend to see a lot of transport of forest fires, the smoke coming to this region. So there's a lot of exciting science there. We tend to see, in our neck of the woods in Maryland, also those impacts. In some occasions, the fires are not from the same location, might be more of a fire that occur more in the southern part of the United States. So there's, how that combines with the local dynamics and how how the air mass circulates in the Mid-Atlantic. It has a set unique impact, and you tend to see more events like low-level jets and bay breeze, and so how that those events that are you can explain heavily with knowledge in the atmospheric dynamics, how that comes into play and impacts the air quality. If you're interested in work in Puerto Rico, there's a lot of remote sensing that we do, trying to understand the transport of dust, mainly Saharan dust, to the region and how that may impact the air in general in that region. Just a quick example, and this is kind of unique features of having these networks, is that we are out there monitoring what's out there in the atmosphere. So we can then provide these type of measurements to the local either National Weather Service or NOAA line offices, and kind of make them aware, of what's happening at any time. So if we look here, so all the air that you're kind of breathing is encompassed in those first 2 kilometers, but you have all the smoke moving across. For purposes of air quality policy and regulation, if that air mass that is polluted here, which we had identified not just by looking at images, but by also combining it with satellite data as well, and chemical analysis data, we know that there's smoke aloft. So if it's not coming down into the surface, it's not impacting anyone. But if it does come down, then we can make out an alert saying, hey, you have this polluted air mass in the area. So and then people can go back and look at the different forecasts that are being issued and make sure that they're actually have proper representation of the condition of the current conditions. This is just related to that smoke dust event that I was showing, and the nice thing is that you can combine that with satellite data, and the satellite data, there's polar and geostationary satellites that we can use their information to kind of look at the evolution of these air masses within the continental U.S. So that kind of reinforces and allows us to aid in the assessment of the events, and especially at the state level, a lot of this remote sensing data is being used as a justification when the local air quality management agencies are seeing exceedances, when the levels of pollutants are going above the EPA mandated thresholds. To kind of put a little bit into perspective, and this is the part that obviously, if there's any students interested, there's a more intensive work that needs to be carried out here. But one of the nice features of being, part of CREST is that we are involved in field campaigns. So the data that I'll be showing here is from one that we conducted last summer in the state of Maryland, in which we had identical monitoring sites with different LiDAR technology at the University of Maryland, Baltimore County, and the Hart Miller Island, which is within the Chesapeake Bay. And one of the key goals of this experiment is to look at the difference of ozone concentrations on land versus water, and how can we really have a better grasp and understanding of either the chemistry or the physics that might be driving high ozone air quality events in the Mid-Atlantic. We had a lot of academic participants that you see highlighted here in red, the institutions in red. It just happens that they are part of the NOAA Educational Partnership Program cooperative science centers, like CREST, and the one that Howard leads, which is NCAS-M, the Center for Atmospheric Science and Meteorology. We also have, and this goes back to what we were mentioning earlier, we have a lot of NOAA collaborators and mentors for our students, and here are listed a few from uh, the Air Resource Lab and the Earth Science Research Lab, and as well as and the National Weather Service. And at the same time, it just happens that we have also, other federal agencies involved. John Sullivan from NASA Goddard, he was a CREST alumni, so it kind of goes back to even, returning students coming back and providing opportunities to you. I'm not going to go through the extensive list. It's for your, this talk and slides will be available to you. The key things that we're looking at into this campaign is how our chemistry and dynamics evolving throughout the day, and what's the driver throughout different times of the day. It just happened because of the nature of the work. Besides of us having ground stations, we also had the opportunity of having a research vessel in 2 different days. And during those days, we had students that actually were participating in our coastal resiliency research program, mainly mentored by faculty here at City College. And they were involved in as well. So with that said, there's a lot of opportunities to be involved in these research field campaigns. And these are just some pictures, some of the students at different times. Just to kind of put it in perspective, the slide with the Cessna view of Hart Middle Island. The island's about 5 miles, so it's in the middle of Chesapeake Bay. So it became a nice opportunity to kind of really, as I said before, see what was happening, how the waters, at least that marine environment, is actually impacting air quality, mainly in the formation of bay breezes and other phenomena. See if this plays out. If it plays, great. If not, no. It's going to take me to the YouTube, so it should play. So there was a part of the campaign, if it plays, that did involve a UAV. So there's some music to it, so you can enjoy it. So you can see the students are about to release an ozone song. So they have a weather balloon coupled to a ozone sensor, and that's going to be looking at that, reporting that ozone concentration over in the air. At the beginning of you can see that our research trailer and the one from NASA with the LiDAR systems as well. Here, that red area there as well. So a lot of opportunities, not just from, as I said here, quality side, that is very interdisciplinary. So even dealing and building, putting together sensors for these different types of remote sensing platforms, that's a key component of our work here. A lot to be done. We just kind of starting to kind of take off with this data. So the panel on top is from the NASA ozone LiDAR system that was at the Hart Middle Island, and the bottom panels are LiDAR speed and wind direction for those events. So each day you can see a period of intense ozone periods that you can see from the profiling from the LiDAR. So how is that really being coupled? What's the driver for those instances where you see the greater amounts close to the surface? So for the 29th, just to kind of do a spoiler, and you'll see more of this in future presentations that we're going to do. You have here really the presence of a bay breeze kind of coming in and impacting the, driving pollutants to the ground. With that, with that said, a key variable or a key area that we look into is this mixing layer heights of planetary boundary layers, because we can really monitor them with this LiDAR technology. So, excuse me. With that said, that's a variable that is key in atmospheric transport and dispersion of forecasting models. And if you have the wrong heights, which is pretty much the other way of thinking about it, it's the size of your box. If you have the wrong size of the box to disperse pollutants in the atmosphere, you can get the wrong forecast. So one of the things that here at CREST that we're trying to do is make aware of the community of the advantage of having this remote sensing technology, and that it should be exploited at maximum capacity and potential. A few years back, the National Academy of Science made this report about observing weather and climate from the ground up, and there was a need for having ceilometers, which is another variation of LiDAR technology, and having regional test beds. So since then, we've been kind of developing a lot of products and trying to lead the community into those efforts. One area that we have a lot of work with is with the National Weather Service, and the nature of the work itself is very interdisciplinary, and we'll get that into a minute. So National Weather Service has these automatic service observing systems, and you have collecting many different meteorological variables. Cloud height, that's what that will be related to a ceilometer, and we came in and kind of made them aware that you shouldn't be collecting just cloud height. You can collect the whole profile and get more information. But one of the bigger issues that we have in these stations is all radio communications. Obviously, technology has evolved, and everywhere you go, there's a broadband and 3G and 4G communications available. So to kind of go down that way, we have partnered up with other departments, and this is kind of to make it relevant to everybody that while we're doing remote sensing and atmospheric measurements, it's tied to computer science and electrical engineering. So, once again, we have these instruments that we can collect data from, but what would be the right way to get that data to the stakeholder, the air quality management agency? Should be all the raw data be going out, or only the data of value? Should we do some processing inside, or just push all the data to have a remote site, and then do the subsequent analysis? So there's different approaches. So we try to, on this particular project, we're looking into compression and decompression of data. For as simple as $35, we had a solution to the problem, but using Raspberry Pi technology. So if you're more into the computer science, this is kind of areas that people are interested with, a lot of cheap hardware, and you can do a lot of kind of cool stuff. With that said, one of the key goals here was to, take this LiDAR data and try to use that Raspberry Pi to compress the data itself to then be pushed out to, as I said, an external site for analysis, or even to take the raw data and do some initial analysis and then just push out the final product. So once again, if you're into compression, decompression, which can lead into fields into having interest in big data science, this is an area that obviously we have capabilities, and we're definitely looking for students in that regard. More kind of the same lines of the ceilometers, and this is current work that we're actually emphasizing, that with EPA and the National Weather Service, is that there's a requirement now for all the chemical assessment monitoring sites to report a hourly mixing layer height. So what's the height of that box where their pollution might be confined to. So with that said, we have been evaluating the technology that is out there and giving recommendation to those agencies on what's the best methodology and instrumentation out there. As I said, the key thing is that we want to be able to capture from these instruments that would report originally cloud-based heights, the whole profile. Also, look at the evolution of that mixing layer height and see, how the different uh, instruments that are out there are handling that data and how they're processing and if they're doing it in an efficient way. And also if besides of just getting a mixing layer height, what other information can you gain from these instruments? A lot of the work comes from codes and published, peer-reviewed journal work that our students within the center has carried out, and it's still, 5 years later continues to be relevant. So that shows you, you are kind of, in the forefront of research if you were to join CREST. These images have the lines in black are showing where the mixing layer height is. The dots are magenta dots are mixing layer heights determined by looking at the potential temperature inversion from a weather balloon to kind of validate. And that's a common practice in this field. So you see that there's good agreement, and the bottom right figure, you just have a combination of the different observations. The top two are from LiDARs, and the bottom one is from a radar wind profiler. So the top two figures are using lasers as a way of measuring this, what's happening in the mixing layer height, while the one at the bottom is using radio frequencies. With that said, we have developed our algorithms to kind of capture what's happening. The image here is showing, our product applied into a Doppler wind LiDAR, looking at the velocity variance. And you see a good agreement with the radiosondes and where everything is kind of supposed to be, is that's where we're finding it. And I'm going to just go through a few of them pretty quickly. Obviously, we have a good confidence, from the linear regression, you can see that. We have looked at different vendors. There's pros and cons with the different vendors. We have a good handle to what they are and how can we improve those several instruments depending on the needs and interests of the community as well. So this is another vendor. And so forth. Area that I want to kind of cover too and make people aware is that we do have the capability to kind of immerse ourselves in offshore wind energy. Recently, the state of New York had made available, made people aware that you can, and I think at this time, parties interested in developing the offshore wind energy area in New York are putting bids. We do have the capability, and we can provide you the academic and skills training to kind of jump into that forthcoming industry that is going to develop, not just in New York, but all along the East Coast of the United States. There's some initial steps moving forward in the West Coast, but a lot is happening within the forthcoming years here in the East Coast. So our remote sensing technology expertise puts us in the forefront. And the nice thing is that you can do research that actually it will influence the public policy, because a lot of these companies that are eventually will build, offshore wind farms, there's credits that each state tends to provide. So by having a very thorough understanding on how that marine boundary layer behaves, can influence how much credit and how beneficial and how successful this wind energy industry will be. The key driver and the nice thing of the United States is that it's a very vast geographical region with in which each one of them with their own characteristic of flow and weather patterns. So one of the key things that we can provide you is with the right tool skills to kind of have a better understanding of what's happening, and the way we incorporate that is of correlating the stability, wind shear, and turbulence within the marine boundary layer, having a better idea, a better grasp of what they are. We have validated the technology, and this is in working together with the folks at NOAA. So this is when the students come in and have that hands-on experience, so we can help, try to have a better, reduce uncertainty in this technology that's actually coming in the forefront in the wind energy industry. In terms of what we can do, and but there's different areas that this lidars can come into play. You can characterize the meteorology. You can see, how much wind is going to be produced. You can validate and improve the weather forecast in that regard. That helps into the energy production or the projected and prediction of the energy at a particular location of a wind farm to be developed as well. And that would actually obviously increases the project revenue and minimum energy loss as well. The image that you see in the top image is just using one of our of the Doppler wind lidar systems available in the CREST network over the Ocean City, Maryland. The wind farm in Maryland is going to happen about 10 kilometers to the right of that image. But one of the key elements is the lack of measurements in coastal sites. So we have to come in, have a proper characterization of what's happening in that interface of land, water, land, air, and air, water. So by having a good grasp of what's happening within those interfaces allows for improvement on future work as it is, for example, in forecasting numerical weather prediction models. A key element to consider here is related to wind itself and power prediction. So, and we'll see the equation in a few slides, but there's a cube relationship between the estimated power that you're going to generate and wind. So with the current forecasting models, we are seeing at least close to 2 meters per second difference on what's being forecasted to what is actually observed in some of these locations. So 2 cubed is 8. So you now a factor of 8 that and for the most part the power is being under predicted. So actually there's a lot more wind energy power that could be generated and that could be harbored if you are making sure that you have a full and good understanding of what's happening in that marine environment, and if the key element there is for those forecasts and numerical weather predictions to able to represent them properly. Just an example, this is just for the state of Maryland. Like I said, the bigger issue in this whole industry is lack of offshore measurements. So because we have this remote sensing technology, it does allow us to kind of venture into that area and do a proper assessment. Out of the key elements here that we tend to look over and over and that people are not aware, a lot of the wind industry is based on the wind having a logarithmic type profile. The reality is, and we'll show some measurements, it's not always what happens. So when that comes into place, okay, are we doing a proper assessment of power based on the principles that are known? So or is there a way of incorporating these new sets of observations with this remote sensing technology to then close the gap of what is the power measured and what was the expected power? And just to give you an example, we've done some work in collaboration with University of Delaware, where the star is located in that figure. Is their turbine is the closest thing that we have in the U.S. besides of the 5 turbines that we have in Rhode Island to actually having something close, a functional turbine. Now, the problem with the turbines in Rhode Island is that there's no nearby platform on which you can put the LiDAR or any type of remote sensing type of instrument. But once again, there's ways of overcoming that, but not at this time. So the nice thing of that, and going back to this is the key equation for those power to the power generated. All the turbines out there have this manufacturer power curve. That's the plot that you're seeing. That the turbines will start generating power at some speed, but that's what's called the cut-in speed, and it would get to a maximum power generation, and you see a large range of values, and then eventually, after you reach the maximum threshold for the wind that a turbine can take, then the power fades out. The key element here, and this is just showing you a power curve with the observations that we have carried out, is that you have a series of ranges of value. Why do you oscillate so much within a particular wind speed, or for in some cases, why you don't get the anything being produced. So one part that we kind of trying to address here is how accurate and precise these power outputs are, and what's really the driver for them. With that said, we have kind of worked into what we call the uncertainty trifecta, and this is where having very interdisciplinary research allows to address properly these areas. So from the atmospheric science point of view, you kind of easily be involved in reducing the wind resource uncertainty. So this goes into the patterns and diurnal evolution of wind in a wind farm, and then the last two are going to be related to the engineering component into how efficient and do the blades are actually accounting properly, or they can resist a load of wind that has a lot of shear or veer at a particular time. So, and to do that, you have to have proper knowledge of atmospheric science. With that said, we have started tackling this by having a weighted wind what we call a rotor equivalent wind speed, which is a kind of weighs all the wind speeds reported within the turbine rotor blade. So that gives at the end a better estimation. The interesting situation is that you can have wind profiles that have these general type of shapes. So the question is, how well is the turbine responding to those, and how can we improve at all the power prediction if we had a good grasp for these? To do that, we actually have a student working in this, what we call systematic evaluation of power predictors. This goes into machine learning for those in math and computer science, in which, we set a model, we look at, for the most part in the wind energy industry, everybody focuses on the wind speed that happens at the hub height. From there, then we started looking at, for example, okay, what are the range of wind speeds that a turbine can work at? Like I said earlier, then that generates an expected power curve, so it gives you a range of potential, ranges of power generated. Then we start looking into precision, error, and the accuracy of the error itself. Then we can then look into the fraction of variance and to see how much it is impacting the power prediction, and if we can improve in the prediction by adding more components to it. So we start comparing the different, either the equivalent winds or the hub height to see how we're improving, and then from there, what's the impact of the different wind profile patterns. With that said, you can incorporate more elements like temperature and turbine performance or blade, a particular blade design within the turbine. So the model itself can become more complicated, but at the same time, it would yield a better predicted power by integrating all these different elements. When we look at that, this is just to kind of summarize what we did in the study. We see that we have these profiles with a strong inflection, so they're the ones that look just like an inverted Gaussian or parabola. And when the profile looks more linear, there's really little to no difference in the uncertainty on that power. So what we are finding out here that you need to have a proper description of that wind shear and wind veer, the change in wind direction within the rotor area of a turbine to have a better estimate of power. With that said, from the science part, I hope that I kind of, got you all excited about LiDAR. Do you want to quit whatever you're doing just to do LiDAR measurements? The truth is in the LiDAR in terms of measurements. That's, it's great to have forecasting and modeling, but measurements is great. And don't get me wrong, we do work a lot with modelers, so we all happy. It's the same community. Uh, with that said, just wanted to kind of cover a few elements of opportunities within CREST. So we do have uh, the scholarship that it applies to undergrads and graduate students in our institutions. There's the key elements of eligibility in CREST is that you are in a CREST institution, that you are a U.S. citizen, and your GPA is greater than 3.0. In terms of benefits, we provide a minimum of $12,000 for up to 2 years. That covers tuition, stipend, and travel. We provide internships to NOAA national labs as well. Our students are participating in national conferences, so they're kind of getting involved with their peers, which allows, to build bridges for, future employment opportunities. At the graduate level, there is 2 tiers if you're doing a master's or a PhD. The reality is that at the end of the day, with all that we provide you, and to put in a different contrast as getting your bachelor's degree, you can go to grad school pretty much for free. You don't have to have that worry of loans. So we do provide you the opportunity. The key thing that you have to do is to apply to one of our graduate programs, and we are very diverse in that sense. We have these 6 partner institutions that we have students that can apply easily over 30 different graduate programs in that sense. In terms of the master's and the PhD opportunities that we provide for the graduate students, they do include and are required to do a 12-week internship at a NOAA lab, which, and you are provided a supplement. That's what falls here under the internship/NERTO topic. So, and a key element too, once again, because we're training you to go into this NOAA workforce, is that as part of your thesis committee, you will have a NOAA mentor. So a NOAA scientist will be part of your thesis because the work that you will be carrying out, as we stated earlier, is going to be tied to NOAA mission goals. The nice thing, and this is something for all of you to consider, is that while, let's say, I'm an electrical engineer student at City College, and I'm interested, obviously, in being part of CREST. I have an interest and a passion for either atmospheric hazards, water prediction, or coastal resiliency. While you can take all your courses, your academic component here at this institution, you can still conduct the research elsewhere in one of our partner institutions, right? That gives you a different geographical component and nature distinct, nature to your thesis as well. Depending on the topical areas, there's a lot of similar infrastructure already in place at those partners institutions that make that transition of conducting some research in City College, or at least, the metropolitan New York area, very easy to conduct, or at least to bring you can do comparison studies at different urban areas for that matter as well, geographical locations. So with that said, we do have also for undergrads, there's these extra scholarship programs. And if you go to that particular website, you should be able to find there's currently 25 different NOAA scholarships. And there's some that are for graduate students and some for undergrads. And with complete different, perform time periods and eligibility criteria. So I would strongly encourage you to go there because there's being part of CREST is great, but there's even more opportunities that you can actually be exploiting as part of this program as well. One of the fellow scholarships that we actually advertise a lot to our students is this one that's called Ernest Holland Scholarship, especially if you're a rising sophomore. It's a nice opportunity. It gives you 2 years of, $40,000 max. Uh, as part of that internship, you are required to spend some time at a NOAA facility in one of the years. There's some still series of talks and orientational component of it that you have to actually conduct at NOAA headquarters. So it does allow you to kind of see how the bread and butter is dealt with on a daily basis when you get that unique opportunity. Summer bridge program. So that's actually something that is very attractive to all the students in our partners institution. So, and it kind of is a nice way to kind of be part of the CREST family. We provide opportunities for the students during the summer. It's an 8-week paid internship. It's about $4,000. The research opportunity is going to be in one of these 3 thematic research areas that we spoke of that I've mentioned. Obviously, I gave you a lot of information on the atmospheric hazard, so if you're interested in doing work here at City College or Hampton University and UMBC, there's a lot to grasp there, and the opportunities are infinite in that sense. One of the nice things is that we provide you workshops for you to increase your knowledge in remote sensing as well as skills in MATLAB and GIS systems as well. One thing for those students that are interested in this particular program, at the end you'll find Cesar Ortiz. He's our recruitment liaison here in City College, so you can contact him if you had any particular information on the opportunity itself. But it's, once again, the opportunity is there. We just need you guys to kind of jump in and be interested in conducting the research. With that said, I'll wrap it up for now. I have you can feel free to email me at any point, contact me. There's a lot more information. I would actually invite everybody to go to noahcrest.org. So obviously there's what I covered here in this presentation, which is probably 5% of the amount of information that you'll find at the CREST website, and not just in terms of just information for scholarships and graduate opportunities, but you can go more in depth to the different research theme areas that we cover. With that said, I'm glad to answer any questions. Otherwise, there's an encore presentation, an encore. Probably go a little bit faster, but we'll go from there. So.
Anybody online has online. Question about
The only thing that we're not offering right now is free iPads, but we'll provide you all the hardware. So it's supercomputers, clusters, whatever you name it. You can calculate whatever you want at a very fast speed. So.
I do have a question regarding the federal collaborators within NOAA. So this CREST LiDAR network that you mentioned, it's at the campuses, but did you mention or did I miss it? LiDAR networks within NOAA labs?
So the CREST LiDAR network it came as a result of having, these grants by the Office of Education. So that's one thing. What you have is that the National Weather Service have this automated, the ASOS network. So they have ceilometers, but the ceilometers, the only thing that they actually are reporting is the cloud height.
Mm-hmm.
It's not actually
Profiling.
profiling at all. So this is the part that all of a sudden people realize, oh, we can get more information out of them. How can we archive that data? The situation with the National Weather Service is a little bit more complex because while the National Weather Service owns the instrument, the one that is operating and overseeing uh, the software used for those stations is FAA. So now you have, FAA saying, no, we don't want you kind of changing anything in terms of what the data that we're collecting until I think it's 2020, 2021. At that point, then the idea is that now you're going to be collecting the full profile. With that said, with everything, there's a new generation of technology that is in sites, and people are realizing that you have more available. The technology that it's going to be available is better, and it's technically a lot easier to acquire that data. And not just that, you will collect the data, but then who's the end user? If you're going to try to simulate data, then whoever you're providing the data may be having whatever requirements on how you provided the data. So, but yeah, right now, currently in terms of uh, the CREST LiDAR network, so there's four sites that are heavily equipped. And heavily equipped might be by more than one LiDAR system. Hampton University, City College of New York, and UMBC. Right now there's a LiDAR in the Ceilometer system, a working Ceilometer system, continuous monitoring Ceilometer system at the University of Puerto Rico, Mayagüez, and I'm in the process of trying to make available to University of Texas El Paso a micropulse LiDAR. So that would allow us to start uh, expanding. With that said, one easy opportunity that we invite others to kind of join us and no free of cost. So as part of a test bed for the Environmental Protection Agency and the National Weather Service, we're putting together like our own mini regional network of ceilometers and LiDARs, and we'll be ingesting as part of that test bed, like the ceilometer data from here, and not just that other academic partners that would like to have their data go through the QC QA that we're going to be putting all those systems for purposes of generating data for the EPA or for the National Weather Service when they actually get back the instruments. Uh, what it's not just academia. We are also in contact with folks within air quality management offices from Virginia all the way to Maine. That's what is known as the Ozone Transport Commission. So because of the mandate that they're going to get, the bigger issue that they have is not that everybody and those air quality management agencies are knowledgeable of atmospheric science, meteorology, or boundary layer dynamics, or even remote sensing. So that's when we would come in and educate those local stakeholders to realize what's good data from bad data, kind of thing. Because a lot of the commercial software that comes with those ceilometers, they would report either one or up to three heights, but it's up to the user to select the proper one. And it's not the case in the East Coast. There's a lot of their quality management folks have people that have some kind of atmospheric science meteorology knowledge. It might not be the case if in the state in the Midwest, because the air quality management office might be tied, for example, to an agriculture or to a mining or a natural resources office. So that's when we would come in and kind of provide guidance. With that said, there's a lot, it's not just from the atmospheric science side that goes into, computer science, cybersecurity, big data. So there's a lot of the research is very interdisciplinary. And at the long run, which is a kind of nice feature from being part of these programs, you're graduating already with a job lined up. So that's a nice thing. So yeah, you have to worry about your at the graduate level. You have to worry about your thesis, defending your thesis. But the you know, but you see at the end of there's light at the end of the tunnel. Let's put it that way. And it's all well received. So
Any questions from the online audience? Oh, there. People are logging in for the second session now.
I guess differently from the first session, we'll do roll call. Try to figure out
Yes.
who's because I see some names, and if they can say from where they are, you can use the chat option.
Yeah.
That would be good. That gives you an idea, the demographics.
Alejandra is from Dr. of Hampton on guest one, so.
Thank you.
Yeah.
Yeah. A lot of science, good stuff goes on at CREST.
But that's it. If you have any other questions regarding to even technical aspects of CREST, and if the folks from City College don't give you the answer, you feel free to email me. I'll find the answer.
Appreciate it.
You'll find that.
Yeah, I'll find the answer. Yeah.
Yes, don't make that effort.
Well, let me put it this way. Well, the lead institution, it's obviously City College. At the end of the day, we all measure equally. So
Yes.
that's the key element here. So that's why that my students are successful. It's great, but the City College students have to be successful. San Diego State students have to be successful. Hampton, University of Puerto Rico, and UTEP as well. Because otherwise, that means that somehow I failed. That's why it's all or nothing. So that's why if you had any issues at your campus, uh, you can feel free to reach out to several folks. One key person here that at least it seems that he's available 24/7 is Cesar. So you can email Cesar or call him for any questions. If he doesn't have the answer, he'll make sure that he gets the right answer. So that's one of those things, it's just a phone call away, an email away. So don't get caught up in a loophole. Just make sure that we'll make sure that you're heard, and that we provide you a reasonable and convincing answer.
Okay.
Ruben, I had to step out for a minute, but I wanted to know any students that came to the booth as Shep online? Did any?
No, so we were saying that for this second hour, we may want to do a roll call to find. We know some of the names, so because we know that they're CREST students, but if there's a guest one, if they were able to identify themselves, if you do, feel free to speak up. We should be able to hear you.
Yes. We discussed the fellowship, but also the Hollings VP. There were plenty of Hollings eligible students.
At the laser
Leadership, yes.
So we just want to do the roll call on the for the students who are online. Alejandra Arcos, can you just speak up and say your name, your degree level, and the campus that you belong to? All the students who are online.
The other option that you have is to use there's this chat feature, right? Am I correct? You can use the chat if you don't have a microphone.
If you have enabled it while setting up the BlueJeans. It's an option. It's not automatically available. You have to go to the advanced features. But Maybe they are.